Hi, and in this video we're going to take a look at automating our designs using iLogic. iLogic is a tool within Inventor, and we're going to take a look at this using a modular building example, looking at drawing automation and aperture entry onto the building. As I said, iLogic is built into the Inventor product, and it quickly allows us to change the configuration of a design, adjusting the model to suit our requirements. In this case, I can enter in 3 main dimensions, width, depth and height, and adjust the module at a touch of a button to those sizes. Because iLogic is built on rules that the designers put in, we're able to put in design checks. So for instance, if I put in a depth that is too large on this building, I'll get a warning asking me to put in a relevant size. This can be whatever checks and criteria we need. By doing this, we validate the output that the factory are going to receive. iLogic can also be used to automate the 2D aspect of Inventor designs as well. One of the most important aspects of any of these projects are the 2D drawings and the building materials. By using iLogic, we can automate the drawings and automate the bills and materials, ensuring consistent look and behavior on both of these elements. By using iLogic, we can then output any drawings as PDF files, either to a central location or attach it as part of the file to put into Vault. If this was required to be part of the design process, we can use tools such as Navigate for Vault, which would allow us to generate these PDFs on document sign-off, i.e. when we release the data. By having this consistent approach, the factory should know where to access the data and should have consistent and real-time access to the latest drawings. iLogic would allow us not just to automate the individual modules, but it automate parts of the module as well. So for instance, I can take a wall and I can start changing the color of the individual panels in that wall. One of the things we come across quite regularly is that the specifications from our customers require different finishes, different appearances, and everyone wants their product to be unique. By using iLogic, we can define a list of options to give to the users. That can be every color under the sun, should we wish it, or we can reduce that list to key options. By doing this, we ensure that anyone selling this product within the company has a set list of options to sell from. Anything over and above that would require additional design time, and therefore additional cost for that customer. One of the key things about modular buildings, however, is that we need to be able to add in doors and apertures wherever we need. And one of the things we've been looking at is doing this with a dynamic approach, where you drop in any window, any door that you require into your model, adjust the size, and we can see real time the size adjusting. And once we're done, we can then set the location of that element. This would work with any type of aperture, so it could be windows, it could be doors, it could be sockets. By using this dynamic approach, the designers of the product can adjust the model in real time in front of the customer if required to their requirements. Quite often, a door or a window will be added and the customer will want it moving or adjusting. Again, this needs to meet the design criteria of that building. So if the door or the window has to line up with certain joists or has to line up with the brickwork in the background, that can all be taken into account. Different type of apertures that we drop in may have different requirements, and we can get any information we want to adjust that shape coming through. So for instance, this door might have options for a single, a double door, an interior door, an exterior door, as well as the colour, the finish, and any other information we require. Again, because it knows it's a door, we only have to adjust the location of it in the width of the building, rather than adjusting the height of the door like we do for a window. By using iLogic, we can add in these apertures wherever we want, but we may have additional design checks to check that the aperture hasn't been added off the product. In this example, we are allowing the ability to add an aperture off the product, but it would be fairly quick and easy to add in a rule that said, well, if the aperture is further away than the width of the building and therefore off the building, prompt the designer to locate it within the wall. Designers don't just need the ability to add in apertures, they also need the ability to remove them as well as the client requires. And again, using iLogic, we can develop a toolkit that allows the users to remove or add these apertures as they need to. Each one of these elements, if we were to do it manually without iLogic, may take up to 2 hours to add each. So the design time, where we're taking seconds, is really saved. As you can see, all the beams have been adjusted, the doors and windows are added in, and once we're done, we can then output the drawing of that individual wall or building. It's not just the PDFs of the drawing that could be output, it could also be DXFs or any other format required for any machining within the factory. Hope that gives you a quick overview. If you've got any questions, please feel free to contact Symmetry.